Good morning, students. Today we shall learn about the refraction of light through prism. I think you must have seen the prism. What is a prism? Prism is a geometrical object which is bound by 5 faces, 2 triangular faces and 3 rectangular faces. Usually these triangular faces are isosceles triangular faces, and the three rectangular faces are bound. So we usually use 2 triangular faced and 3 rectangular faced bound prism for the study of refraction in the laboratory. So what happens when a ray of light travels through a prism? It was a very interesting thing which was done by Sir Isaac Newton. He found that when the sunlight was allowed to pass through a prism, it split into 7 colors. It formed a beautiful pattern of 7 colors. And later on, that beautiful pattern of 7 colors obtained on the screen was termed as spectrum. And this phenomenon of splitting up of sunlight into its 7 colors, this phenomenon was termed as dispersion. This phenomenon is termed as dispersion. The cause of this dispersion is the refraction of light through the prism. We have studied earlier the refraction of light through a rectangular glass slab. When the light passes through rectangular glass slab, you saw that the incident light and the emergent light, they went parallel to each other with a slight deviation between them, with a slight shift between them. And that shift between the incident ray of light and emergent ray of light is called as lateral shift. And we drew the diagram for that lateral shift. Now what happens in the case if a light passes through a prism? Let us say the light is not sunlight, the light is not a white ray of light. Let us say it is some single colored light. Let it be a red light or a blue light or yellow light. If a monochromatic beam of light, if a monochromatic light ray enters into the prism, what happens? Monochromatic means, mono means single, chrome means color, monochromatic means a ray of light with single color. If a monochromatic ray of light enters through a prism, what happens? Definitely prism is a medium with high refractive index. So the ray of light bends inside the prism and refraction takes place. What happens? The ray of light comes out from the prism. That's what we are going to see. So here we are taking glass prism. So glass prism is a geometrical object, a geometrical regular body having 3 rectangular and 2 triangular faces, 2 triangular isosceles triangular faces. So if you draw it, the prism appears like this. All the 3 sides must be equal. So if you join this forms the prism. So you can see 1, 2, 3. 3 rectangular faces, front one and back one, 2 triangular faces. This is a prism. So for our study of refraction through prism, we just take the schematic diagram. We just take only front face. You see, we see only one front face, triangular face, and other 1, 2, 3 and 4 faces are not seen. So what happens when a ray of light enters? Suppose this is a monochromatic ray of light. Monochromatic So if you draw a normal here, normal to this face, this is the normal. Then you see this is a glass prism. So let us call this glass prism as ABC, and let us take this PQ as the incident ray. So naturally it enters into the denser medium, so it bends towards the normal. This is the normal, it bends towards the normal and travels through the prism, and this I will call it as R. QR is the refracted ray. Now what happens when it comes on the other face? See here, this is one face, this is the other face. When it reaches here, you see the ray of light is entering from glass into air. So we draw one more normal here, normal to this face. So this is the normal drawn to this place, and when the ray enters from denser into rarer medium, you see it bends away from the normal. Here it bends towards the normal, and here when it is emerging out, it is bending away from the normal. So this becomes emergent ray. So PQ is incident ray, QR is refracted ray, and RS is emergent ray into the air. Let us say this is surrounding medium, that is air, and this is glass prism. So this is how refraction of light takes place through a prism if it is a monochromatic ray of light. Now if it is a white ray of light, what happens? If it is a white ray of light, this was first done by Sir Isaac Newton. If it is a white ray of light, see here, if you continue this PQ, this would be the undeviated path of the ray. If the prism would not be there, the ray would have continued in this straight line path. When we keep the prism, the ray of light bends and undergoes deviation. So if you measure this angle here, so this angle here gives us the angle of deviation. The angle of deviation. So what is angle of deviation? First we write. Angle D is called as angle of deviation. If the prism would have not been there, the monochromatic ray would have been continued in the path of PQ, straight line. After keeping the prism, the ray had undergone refraction, bent toward the normal, and reached the other face at R. And after reaching at R, again it bent away from the normal since it is entering into air. So RS becomes the emergent ray. So if you produce this RS backwards and produce this PQ forward, at one point they coincide. This point, at least they coincide. This point is named as D, and here we get the angle of deviation. Angle of deviation means the angle through which the incident ray has bent. The angle through which, you can see here, this is the incident ray produced. The angle through which this incident ray has bent to form the emergent ray. The angle through which the incident ray has bent to form the emergent ray, that angle is called as angle of deviation. You can write here. The angle through which the incident ray bent to form the emergent ray. deviation. It is denoted by D. Okay. Now we have taken monochromatic ray of light. Monochromatic means ray of light with single color. Single color, then you are going to note down that color is due to its wavelength. So a ray of light with a single wavelength is called as monochromatic ray of light. Here it is white ray of light. Or you can say sunlight. When sunlight is made to pass through a prism, what happens? Again, let us take prism ABC. If this is an incident ray, undeviated path of the incident ray, then you will find the bending of this ray of light, and along with the bending, this ray of light splits into 7 colors. One, two, three, four, 5, 6, 7. And these rays, when they emerge out, again they bend away from the normal in this fashion. So if you keep a screen here, we get a beautiful pattern of 7 colors. And you will find that the top one will be red and the bottom one will be violet. So in between you will get all other colors. So we will get violet and red at the top. The top color is red. In between you will get indigo, blue, green, yellow, orange, red. So we get the pattern like this: violet, indigo, blue, green, yellow, orange, red. So with Dior, you can remember it as whipped Dior or whipped Dior, whatever it is. So red is least bent and violet ray of light is bent most. So this phenomenon is called as dispersion. So it is called as dispersion. What is the meaning of dispersion? When a white ray of light is incident on a glass prism, it splits into 7 colors. This process of splitting up of white ray of light into its constituent 7 colors is called as dispersion. So I write here, what is the meaning of dispersion? The splitting up of white ray of light or sunlight into its constituent. Constituent means the ingredient. Constituent means the ingredients. What are the colors which are there inside white? Constituent. 7 colors. Is called as dispersion. It is called as dispersion. And this beautiful pattern which is obtained on the screen, you see this is the screen, the beautiful pattern of these 7 colors, the beautiful pattern of these 7 colors obtained on the screen is called as spectrum. Constituent 7 colors on the screen is called as spectrum. The phenomenon is called dispersion, and the pattern that is obtained on the screen is called spectrum. Don't get confused. Now you see one important thing. If you measure the angle of deviations, angle of deviation of red is least and angle of deviation of violet is most. That's why the splitting up of 7 colors take place. Why does it happen? It happens because every color which appears here finds different value of refractive index. It finds different value of refractive index of the glass. The glass shows different value of refractive index for different colors. As a result, the ray of light bends with different angle of deviation to form a spectrum. I think you got it. The angle of deviation which you are going to get here, D, for red is minimum and angle of deviation for violet is maximum. So the reason for this difference in angle of deviations for different colors is the refractive index of this glass, that is optical density of this glass. Optical density of this glass is different for different colors, different for different wavelengths. As a result, they have a different paths. They will have a different path. So this is the reason why splitting up of 7 colors take place when white ray of light enters into glass medium, that is enters into a prism. This was first found out by Sir Isaac Newton. So the spectrum was studied for the first time by Sir Isaac Newton, and he is the person to state that the sunlight, later on white light also, the sunlight is said to have 7 colors. You might have seen the rainbow just after the raining, if it is drizzling, and if you observe the sky opposite to the sun, if it is drizzling, if you observe the sky opposite to the sun, sunlight should be there. You will find a beautiful arc, and if you observe in that beautiful arc of colors, you will find 7 colors, out of which this violet and indigo will not be seen prominently. You will see other colors, blue, green, yellow, orange, red. Violet and indigo will be seen very faded. Intensity of this violet and indigo is very low, which cannot be seen prominently to our eyes. So this is the refraction that takes place in our nature, that is atmospheric refraction. Due to atmospheric refraction, the rainbow appears when it rains, and during the raining there must be sunlight. If there is a sunlight daytime, if it rains, then if you observe the sky opposite to the direction of sun, you will find a beautiful arc of 7 colors, that is called as rainbow. So this was studied experimentally in the laboratory by Sir Isaac Newton. How did he prove that the white ray of light consists of 7 colors? Okay, that we will see by drawing one more diagram. So in order to study the dispersion clearly, in order to obtain these 7 colors, prominent colors clearly, Sir Isaac Newton took 2 prisms and he wanted to analyze clearly. So he kept one prism erect straight, another prism inverted in contact with each other. ABC is an erect prism as it is here. PQR is another prism, second prism, kept inverted side by side. When he allowed white ray of light, the white ray of light is also found to be having 7 colors, same with GR. So he found that I have drawn only 2 colors for our understanding, violet and red. So these in between colors also you can just show. Violet, indigo, blue, green, yellow, orange, red. So these 7 colors are reaching here. When they entered into the second prism, you see, which is kept inverted. Interestingly, they got inverted. They got inverted and the reunion of all those colors took place. So this becomes the inversion of the spectrum. Reunion of all these colors, violet to red. When they unite together, they again gave out, interestingly, white ray of light. The ray of light which comes out here, emergent ray of light from the second prism, is interestingly found to be again white ray of light. That's how Sir Isaac Newton proved that the sunlight and thus the white ray of light consists of 7 colors. White ray of light consists of 7 colors. This is the inversion of spectrum. And this showed that reunion of all 7 colors to give you white ray of light. This shows that white ray of light consists of 7 colors. You must have heard one Kannada song. ಏಳು ಸ್ವರವ ಸೇರಿ ಸಂಗೀತವಾಯಿತು, ಏಳು ಬಣ್ಣ ಸೇರಿ ಬಿಳಿಯ ಬಣ್ಣವಾಯಿತು, ಏಳು ಸ್ವರಗಳು ಸೇರಿ ಸಂಗೀತವಾಯಿತು, ಏಳು ಬಣ್ಣ ಸೇರಿ ಬಿಳಿಯ ಬಣ್ಣವಾಯಿತು. Means if 7 colors reunite together, it gives white ray of light. That is the wonder of that magic number 7. Okay. Now you can just conclude that the red ray of light bends least with minimum angle of deviation, and violet ray of light bends most with maximum angle of deviation. Maximum angle of deviation. So tomorrow we will study the very interesting phenomena that take place in the nature. That is atmospheric refractions and applications of refraction in the nature. Thank you. Have a nice day.